Hello, Assalamu alaikum. In this video, we are going to talk about another tutorial on Smart PLS using the version 4. Uh, Today, actually, we will practice the measurement analysis or measurement model analysis, right? So, we'll use the Smart PLS 4. So, if you are not familiar with measurement model, so in that case, you can see the previous video to understand what is the measurement model. On the other hand, there are some others model, right? The formative model, structural model, right? Or formative and reflective model. But today we'll talk about the measurement model, right? So how we'll do it and using the smart PLS, how we can solve it, we will learn today. So first of all, we need to know the basic or the theory of measurement model, right? So let's start. First of all, you need to prepare the data. I mean, prepare and input the data. So we think about or we're ensuring or you have to ensure that your data is prepared, right? So your data may be in Excel file, I mean Excel format, or you can keep it in a CSV format, right? So both files uh, recently is read by the Smart PLS 4. On the other hand, actually some others file like SPSS file is also compatible for Smart PLS 4. But in up to the version of Smart PLS 3, we needed to use only the CSV file, right? By the way, first one is prepare the data, right? So please ensure your data is prepared. Second one, create the new project. How we will create a new project, we'll learn in the hands-on project, right? Third one, create the reflective model. So what is reflective model? What is formative model? Please see the previous video to learn what is the reflective model and what is the formative model. Today we'll create a reflective model, right? So then we'll define the relationship. So we'll define the relationship. It means I need to create some arrow signs from the indicators variable to the construct or the dependent variable, right? Or you can say that from independent variable to dependent variable, right? So then I will or we will estimate the mode, right? I mean calculate the result, okay? And finally we'll do what is the value of model fit. So usually we use standardized root mean square residual, I mean SRMR value, right? So if the SRMR value is less than 0.08, right? So in that case, you may see your model is best fitted, right? Okay. But when you see, in many cases, I noticed many cases when the value is less than 0.09 is also fine, right? But if the models, I mean SRMR's value will greater than the 0.09, then you need to rethink about your model and you need to think about your model is not fitted at all, right? Okay, so first of all, we will see what is the value of SRMR. Then we will see the outer loading. Some people say it's a factor loading, right? Outer loading, factor loading is the same actually. Okay, so good indicator is indicates the greater than 70%, I mean 0.07. On the other hand, theoretically, from 40% to 70%, I mean zero point 0.4 to zero point 0.7, it's acceptable. But to be honest, if your value is less than zero point 0.6, right, outer loading value, so your model will not fit uh, good at all, right? So theoretically, though theoretically 40% to 70% is acceptable, but honestly speaking, if your factor loading is less than zero point 0.6, you will not get the good result. So in that case, to secure your model, so please stay or try to keep your factor loading greater than at least 60%, I mean 0.6, right? On the other hand, then we'll check the convex alpha value. So it's very good if the convex alpha value is greater than 70%, I mean zero point 0.7. On the other hand, then we will see the composite reliability, right? This also should be greater than zero point 0.7. Okay, next we'll uh, check the convergent validity. Actually, convergent validity will check using the AVE. AVE, it means average variance expected, right? So when you will see the AVE value is greater than 50%, right? So in that case, you will see your convergent validity is fine. Okay. Finally, we will check the discriminant validity. So discriminant validity can be checked in two ways. One is Fornell-Lacroix criteria, and another is HTMT, heterotrait and monotrait ratio, right? So what is this? Actually, when you see the FL criteria, please see here, square root of AVE is greater than correlations between the construct and all other construct. Each indicator should load more highly on its own construct. So maybe you will facing some problem when I'm reading it, but when you will do practice it, I will clear it more uh, loudly or clearly, right? On the other hand, HTMT value, the HTMT value should be less than zero point 0.9, I mean less than the 90%, right? So for multicollinearity check, we will check the VIF value, right? So what is that? Multicollinearity or collinearity is a situation where the predictors in a regression model are linearly dependent. What is this? We'll learn when we will practice. Objective ensure that multicollinearity is not destroying the model's estimator. So what is multicollinearity? To be honest, multicollinearity is when the independence variables will correlate with each other, right? So model will be biased, right? In that case, we need to control the multicollinearity, right? So using the VIF function, variance inflation factor, I forgot it actually. So using the VIF, variance inflation factor, right? We can check. So normally, honestly speaking, for theoretical purpose, wrote here, VI value should be less than 5, and it should not be higher, greater than 5. Honestly speaking, if your value is greater than 3, right? VI value is greater than 3, maybe you will fall in a problem, right? You need to you must ensure that your data have the multicollinearity problem, right? So though theoretical purpose I write here, the value should be less than 5. To be honest, when you practice, please keep in mind this value should be less than 3. Okay. Okay. So at the final output, we will check the assessing indicator reliability. I mean the outer loading or indicator loading, or someone says that the factor loading, right? So also we'll check the consistent reliability, where convex alpha value rho rho a, there is another statistics that's value, right? And we'll check the convergent validity using the AV function, right? And also discriminant validity using the Fornell-Lacroix criteria and the HTMT value. And to be on, finally, the model fit should be 0.08. I mean, less than 0.08, right? So thank you to see this um, theory, right? Now it's time to practice. Okay. So just to go to the smart PLS, and I'm clicking here, run as administrator. Okay, yes, right. I'm just opening the smart PLS, and first you need to select your first workspace. So please select your first workspace. Uh, I'm sorry, it's quite slow. Oh my God. God. Okay, so select your first workplace. Just click here. Probably I will store my data is in here. For example, here, right click here, uh, create a folder, smart PLS 4. Okay, so I will store all the data and project here. Okay, just select this one and select folder. Click select folder. Now you need to create a workspace, or we have already created a workspace, right? So here are some archives. There is no project is in here. So create a new project. For example, click here, write, uh, for example, ERP practice, practice, right? Here, oh no, measurement model practice. Okay, measurement model practice. Just create here. So when you create this, you don't have the data file, right? So there are two options is in here, are in here. So one is import the data file, then create model. So first you need to import the data file. So create here, and my data is in desktop, right? So I put the data in ERP. So here is the data file. So both the file is readable. I mean, this is the CSV file and this is the Excel file. So I'm selecting the Excel file as I'm using the Smart PLS 4. Just click open. So after clicking the open, you will see some statistics in here, right? Some mean value, max value, and everything is in here. And all the variables and measurement items are in here, right? Okay, just import. When you will click the import, it's a magic. All the descriptive statistics are in here. Here you will see all the indicators name, I mean the items name. There are some serial numbers. It's a mate type, right? So mean, median, minimum, maximum, observed minimum, observed maximum, standard deviation, skewness, kurtosis, right? You will see here skewness, kurtosis, and the uh, value, I mean the significance value. So you can copy and paste, I mean copy to Excel. Okay, you can go to in Excel. So Excel file. Okay, click here. Just okay. So for your future purpose, maybe you can save it, right? So how you can save it? For example, we will save it in ERP folder, right? uh, Descriptive statistics, for example, DS, descriptive statistics. So here we can identify the skewness and kurtosis, right? So okay, so just deselect here and just go back. Right now it's time to create a model. It's time to create a model, measurement item practice. Name of model, chose, I need to choose a model name. We will use the PLS SEM. There are some other model, regression model, process, covariance based SEM, right? GSCS, right? We will select the PLS SEM. Here we will see a measurement model practice. Okay, just save. Right now we have a workspace. Please see here, there is a workspace, and please see here, all the items are in here, right? All the items are in here. So we need to create a model. So which model actually we will create? So please, before come to this stage, I strongly believe after reviewing the literature review, you identified some gap of your research, right? And after that, after reviewing the literature, you created a model. It could be a conceptual model. It could be a other theoretical model. Theoretical model means you can uh, use the TAM model, I mean technology acceptance model, TBP model, and UTOD model. It depends on your research. But for tutorial purpose, actually, this is one of my published paper, right? It's on ERP. I created this model. It's the conceptual model actually. So how we can I created this conceptual model. Maybe in another video, I will try my best to understand you how we can create a conceptual model, right? What is the scientific way? Okay, so we will here 1, 2, 3, 4, 5, 6, 7 factors or construct, right? So first one is top management support. Okay, just latent variables. Click here, latent variable, right? So top management support, there are three items is in here. Just drag and drop in here, right? Top management support, just enter. Okay, so if I see this value, I mean for yeah purpose, select, okay, and just make it a left side. Okay, so top management support is in here. Okay, so what is the next one? Extensive competent team. So ECT, extensive competent team. ECT have 5 items. Just drag and drop in here, right? Click enter. Okay, I'm just selecting here. Okay, this is the ECT. Okay, so here PIT, post implementation training. PIT, what is the PIT? Yes, the PIT, post implementation training, has three. Let's drag and drop in here, enter. Okay, it's quite okay. I'm putting this one like this, right? Okay, and next one is IDIS, Inter-Department Information Sharing. IDIS. Okay, so IDIS, 3 items, right? So IDIS is in here. Okay, so IDIS. Okay, uh, okay. The IDIS, I am making it the left side, the measurement item, right? The next one is continuous system development, CSD, continuous system development. Here, CSD, 3 items, right? Drag and drop in here. Just enter. Okay, this is the continuous system development. And here you will see the decision support unit. So I'm making it the right corner. The DS, decision support, DSU, have the 3 item DSU. Okay, so DSU have the 3 items, right? Okay, and finally the business process performance, BPM, business process performance, have 5 items. So this is business process performance. Okay, so I make it in here, right? So we have already created this model, but still we see here, when you go to the this is to define the relationship. So first one, prepare the data. Second, we prepared the data. Second one, created a new project. We created a new project. Create the reflective measurement model. Actually, we need to create the reflective measurement model, right? So here, please see, define the relationship. So based on this theoretical model, I will define the relationship. So how I will define the relationship is to connect in here. So number 1 is in here. Just click here. 2, 3. Okay, that's great. 4, extensive to hypothesis. 4, extensive PTI. So extensive to PTI 4. 5, 5, 5. It means extensive to DSA, and this is the 5, right? 6, extensive to CSD. This is the 6. 7, PIT to IDIS, right? 8, post implementation to, yeah. So in this case, just select, I'm just putting it here, right? To okay, okay. So that so this is the 8, 9. So connect here, 9. This is the 9, 10. Continuous development to decision support unit, and 11, right, this, and 12, this one. So please see here, you have already created, or we have already created this model, right? Okay, using this model. So what is the next one? So estimate the mode, right? Click on the calculate button to run the model. Okay, so this is our model, conceptual model, sorry, this is our conceptual model we created, and now it's time to calculate. So just click here, calculate, and click here, PLS SEM algorithm. Sorry. So start calculation, you will see the result, right? You will see the result. Okay, estimate the mode. Now, what we need to check first actually? So first we need to check the SRMR value. So click here, the model, right? What is the model? Uh, uh, Model fit, right? So please see here, SRMR value is structured in 12, right? It's a 12. So we can say the model didn't fit well, okay? Because it's somehow the dummy variables, okay? So next one, so it means the model is poor model fit, right? So we will try our best to make it uh, a good model fit, okay? So next one, see the outer loadings. Okay, see the outer loadings. What is the outer loading? This is the outer loading. Can you please see here? There are some values. For example, here this is less than 60%, and here this is less than, oh my god, only 11, right? 0.11. So BPP5 and PIT2 should be deleted. BPP5, this one, less than 60%, and PIT, I forgot, PIT2 maybe, right? PIT2. Just delete it, save it, calculate. Okay, right now the model fit. Right now we can check the model fit. Can you please see here? The model is quite fine. It's reducing, right? Okay. So, oh, I'm sorry. This is the model. Calculate, posting, calculate. Okay. So outer loading. Here, all the outer loadings are fine because we said here the outer loading should be greater than 70%, right? So our outer loadings, all the outer loadings are greater than 70%. Okay, it's good. It means all the items are fine. We deleted two items because uh, it's less than 70%, right? In many cases, in some cases, you can keep less than up to 0.6, right? But I suggest you not to use which value is less than 70%. Okay. So next one, oh sorry. The next one, convex alpha value, right? So we need to check the value, I mean the construct reliability and validity. The construct reliability, please see here, all the construct reliability are good except the PTI, because PTIs, what is PTI? PTI 0.7, 90%. Okay, only two variables, maybe some other problems actually, right? Some, maybe some, there are some multiplicity or others problem. That is why PTI is a problem. But honestly speaking, in many cases you can keep it because path coefficient, sorry, not path coefficient. It's the construct reliability validity. In some cases, statistically significant, which is greater than 60, right? All the other variables, for example, composite reliability, ROAs, and AVs, please see here, all the AV value is greater than 50%. All the values are greater than CR. All the values are greater than 70%, right? Okay. So, it's done, right? Convex alpha, CR value, it's everything is done. Okay. So now let's check the conversion validity, right? Conversion validity, it means this one, AVE. So AVE is greater than 50%, right? So data ensured the conversion validity. Okay. And then the discriminant validity. So we need to check the discriminant validity. So here is the discriminant validity. Please see here. First one is the HTMT, right? Heterotrait and monotrait, heterotrait. So please see here, there are some problems within the data side because this correlation is greater than zero point 0.9, I mean 90%, right? So it's greater than, so it should not be the ratio, sorry, this ratio should not be greater than 90%, right? That is why our model fit is not good at all, right? Okay. On the other hand, we can see the Fornell-Lakers criteria. Please see here Fornell-Lakers criteria. I told here each indicator should load more highly on its own construct. What does it mean? It means, please see here, 81, right? So please see here, all the values is less than 81. 83, all the values is less than 83 except this one, because there are problems in the data set, right? On the other hand, please see here, all the values are in 80%. All the values here are, yes, there is a problem, right? So the discriminant validity actually didn't fool the criteria. But when you will see this top value is greater than all this value, I mean this one greater than all this value, this one is greater than all this value, this one is greater than all this value, and so on, right? Then you can say the discriminant validity was is good, right? At the same time, same, think about in this way. For example, 85. So see here, all these values should less than 85. It's a 86. All these values should less than 86. 88. All these values should less than 88, right? So when you will see these types of values, you can say the discriminant validity fulfilled the criteria. So I think you understand this one, right? Okay, and final stage, multicollinearity. So we'll check the VIF value, right? So what is VIF value? uh, this is the collinearity test. Can you please see here? All the values are in fine, right? All the values are in fine, less than zero point 0.3, but one values IDIS2 is slightly, it's fine. It's not a big issue, right? So it means there is no multicollinearity issue in this model, right? Okay. So which is the last one? So this is the last one. In this measurement model, we checked the uh, outer loading or indicator loading, or in some cases we can say that the factor loading, right? So all the factor loadings were greater than 70%. Two factor loadings are less than 70%, and we deleted that from the model, right? I mean those variables items from the model. Then we checked the consistence reliability, what was checked by the value of convex alpha and the RHOA, and it can be divided into two ways, right? So one is, the most important is the CR, I mean uh, CR value. So this both should be 70%, I mean should be higher than 70%, I mean should zero point 0.7, right? So we assessed the conversion validity using the AV function. We noticed that all the values of the AV value are greater than 50%. And finally, we noticed, assessed the discriminant validity using the Fornell-Lakers criterions and the HTMT. But in our model, I mean this practice model, actually there are some problems of discrimination validity, right? Okay, that is why our model's fit is quite model fit is sometimes acceptable, right? When though we say that it should be 0.09, but it's 11. It's sometimes, it depends on research criteria, project criteria, how many how we control my data collection, or how much error we consider during the data collection, right? So it depends actually. So it's not bad also, only 0.02%. It will not hamper or impair in your business, right? So this was all uh, about the measurement model, right? So in this video or tutorial, we learned uh, how we can calculate the measurement model or measurement model analysis using the smart PLS 4, right? And we learned some practice or theory, and using a model, I mean conceptual model and a data set, we calculated using the smart PLS 4, right? So after the next video. Thank you so much, right? By the way, if you have any question, if you have any suggestion, you can write on the in the comments box, right? Or if you find any fault on my lecture, just let me know, right? Because I usually don't edit my lecture. That is why maybe there are some language slagging or any others, right? So I accept your suggestion and comments, right? Okay, after the next video, keep me in your prayers. Okay, Allah Hafiz, bye bye.